Hey everybody, welcome in. I'm Mr. Biter, and today we are going to learn about the sun, without which you would not be here, nor would I. We need the sun. Now, the sun is the closest star to Earth, so you might look up at night and see all kinds of stars and be fascinated by them, but by studying our sun, we can actually study all those other stars as well, because our sun is a star. What kind of star is it though? Because there's many different kinds of stars. Our sun is a medium-sized star. It's middle-aged, about 4.6 billion years old, halfway through its life. It's going to live another 4.6 billion years or so. And it is a yellow-colored star. Now, our sun and stars, it has four main layers. We have some internal structures, like the core, the radiative zone, and the convection zone, and then we have the outer zone, which is the atmosphere. Now, the core is where all that magic happens to make the heat and light that makes life possible. It's through a process called fusion, where we have two hydrogen come together to form one helium. So those two protons that are in those hydrogens fuse together to make one helium, which is two protons and two neutrons. Now, this process gives off lots of energy, and that's the energy that comes out of the sun to the earth that we can use then for all our life processes and to power almost everything else on earth. The zone right outside the core is called the radiative zone. And this is where we have a whole bunch of that light, that energy that comes out, actually gets radiated out from the core. But it's amazing to think that it takes thousands of years for it to radiate out because it bounces around so much within that radiation zone. So it takes a long time for that energy to leave the core and get to the next layer, the convection zone. Now, convection is where that hot interior rises and it cools and it sinks again. But eventually it does carry that energy outward towards the next layer, that outer layer of the sun. This is where we group into all these into what we call the atmosphere of the sun. Now let's take a look at what this outer edge of the sun looks like. This is an image, a video produced. Each of these little cells you can see is about the size of Texas, and it's bubbling and roiling. And this is a very recent image. Scientists didn't know actually what this looked like for the longest time. So this is fascinating to be able to see this in great detail, to know what the sun actually looks like. Now, that surface that we can see is called the photosphere. The photosphere gives off most of the energy in light. This is what we can see, especially we have good filters on our telescopes, or we have special filters on glasses we can look at, and where we can see the sunspots forming on the surface of the sun. That detailed image of the edge of the sun, that outer layer, it's a chromosphere. This is what gives the sun its color. And also where we can see those solar prominences, these loops of gases happening and coming out of the sun. Now going out from that edge of the sun, that outer piece of the sun is the corona. It's spewing out further and further out into our solar system. This is the outermost layer, and it can only be seen during solar eclipses and with specialized telescopes. And this is where we release that solar wind that can affect the Earth. Now, those sunspots that we saw are important because that is caused by strong magnetic activity. And you can see that they're darker than the rest of it. That's what enables us to see them. And they're often in pairs because this is where we have these looping magnetic effects. And it goes on an 11-year cycle. We have increasing solar activity, more and more sunspots, and then it goes down again in an 11-year cycle. All this magnetic activity, these looping prominences, can have an effect beyond the sun. We'll see that soon in these notes. Now, look at this perspective with these sunspots. The Earth is tiny. It is much smaller than this sunspot that's in the middle here. Jupiter itself is only just covering all these spots here. So you can see the vast size that the sun is compared to Earth. That a sunspot is bigger than the Earth. Now, these solar flares happen when we have these prominences, these magnetic loops coming out of the sun with these sunspots, and these intense bursts of radiation. These are huge explosions that go out into the solar system, and these are these coronal mass ejections. There's huge bubbles of gas and magnetic fields that are released from the corona, and they can spread charged particles far into the rest of the solar system. And we can see that here in these images. You can see these massive loops coming off the sun. It's kind of terrifying to see. And this has an effect on our solar wind. All this ejection of these charged particles, this continuous stream of particles that flows out from the sun in all directions. And we are protected, thankfully, by our magnetosphere. But we can see its effects when we see the northern or southern lights, the auroras. We can see how that magnetic field of the Earth is protecting us from all that solar wind and all the energy in it. It can still be dangerous to our astronauts as well as satellites that are in orbit around the Earth. Here we can see a little video depiction of our coronas, these loops on the sun that are, in a way, expelling all of this solar wind, all these charged particles leaving and going out into the solar system. So thanks for watching this. I hope you learned something, and I'll see you later.